Hello, welcome to the screencast of 3.4 exponential and logarithmic equations. So a exponential equation literally is an equation containing a variable and an exponent. So this is 1. 3 to the 2x plus 3 equals 7. Right, because I have a exponential. Awesome. Here, equations always include an equal sign. Since the bases are the same, what I'm going to do is just set the exponents. Because both have a base of 2 and they have to be equal, I'll set 4x plus 1 equal to 2x minus 3. And then I can just solve for x, yada yada yada. So negative 4 is 2x. And then we see x equals negative 2 for this first example. So one idea is to make the base the exact same. That way I could just set the exponents equal to each other. But if we go back over here to the left, the example over here, it is a little more difficult. All right, so this is a little bit of a harder one because I can't rewrite 7 in terms of 3, in terms of a base 3. So we'll see how to solve that in a second. Okay, so once again, if 3 to the x equals 3 to the 5th, then guess what? Your exponent is 5. If log base 10 of x equals 3, then I could say 10 to log x is equal to 10 to the 3. So literally, I put each power as if it was the exponent for 10. Right, so 10 to log x equals 10 to the 3, and guess what? This log, since it's a common log, so that cancels out, and I see x is equal to 10 to the 3rd. So those are like our two ways of solving. I either rewrite so they have the same base, right? So they're both in, exponential with base 3, or maybe log. Maybe they're both going to be log base 10, whatever. Or I'm going to, like over here, this is where I'm going to be putting each side as if it's the power of some base. All right, let's try example A. So on the left side, I have a base 4. I can rewrite 16 as literally 4 squared. X minus 3, 4 to the x plus 2. All right, when I have an exponent to an exponent, I'll multiply. So I have 4 to the x plus 2 equals, and so I was talking about an exponent to an exponent, I'll multiply. 4 to the 2x minus 6. Since I have the same base, I'm going to set the exponents equal. So 2x plus 2 equals 2x minus 6. I'll add 6 on both sides and subtract x. I have 8 over here and x. X equals 8. Feel free to pause the video at any time. Try the problems out yourself before I go over them. Okay, can I rewrite 181 in terms of 1/3? Let's see, 1/3 squared is going to be 1/9. And I know 1/3 to the cube is going to be 127, so this is going to be 1/3 to the 4th. And of course, this is all to the 2/3. And then 1/3 to the n. Okay, well, an exponent to an exponent, right? So right here, I have to multiply them. I have an exponent to an exponent, so I'll go ahead and multiply. I have n is equal to 8 over 3. I'm matching up the exponents since the bases are the same. Okay, now I have an issue. I can't rewrite 13 in terms of 4 to some power. So the first thing I'm going to do is I'm going to, well, let's see, I have x is in the exponent. So what if I take log base 4 of both sides? So I have log base 4 for the x equals log base 4 of 13. Well, I know that, let's see, log base 4 of 4 to the x, 4 to the y is equal 4 to the x. So literally, your y value is just your exponent, so that's why that cancels out. So I have x is equal to log base 4 of 13. Cool. All right, so my first step was, getting the exponential by itself on one side. All right, so I got the exponential on one side. Then I used log to get rid of the exponent, aka now, guess what? Now I just have x by itself. And now I'm going to use change of base so I can actually solve for x, because a lot of graphing calculators do not have the ability to do a log with a base other than e or 10. So we can do change of base. It's a good little review. So x is going to equal log base 13, log, let's see, I'll have it be common log, which is 10, 13 over log of my old base, which was 4. So this is roughly 1.85. Cool. Try out D, see if you can figure out how to do it. Okay, so I cannot write E as to the power equaling 8. This is going to be some nonsense, whatever, decimal. I don't want to do that. So what I am going to do is I'm going to take ln of both sides. Okay, so I know from rules of logs, I can move the exponent out front. So I have 2x plus 1 times ln E equals ln 8. So ln of E, well, that cancels out. That's just going to equal 1. So I have 2x plus 1 is equal to ln of 8. Subtract 1 on both sides. Ln of 8 minus 1. And then divide by 2. So x is going to just be ln of 8 minus 1 all over 2. Okay, and then if I plug that in, that's roughly going to be about 0.54. So I got the exponential by itself on one side, check. I took log of both sides. I got rid of the exponential, so that way I just have the exponent by itself. And then I went through and solved, got x by itself. All right. Whew, that was exponential. Now let's talk about logs. Logarithmic equations. Guess what? Log base 2 of x, if that's equal to log base 2 of 6, same log base, and now x is equal to 6. Similarly, this is the exact same thing that we're doing, literally taking log of both sides, but maybe I could raise each side, have each side be the power, whatever. I think you'll get it if I do the examples. All right. Solve the following logarithmic equations. 2 ln of x is equal to 18. First step, get this, get the log by itself. Get log by itself. Divide each side by 2. I have ln of x is equal to 9. Now I'm going to, it's not raise each side to the power of, but literally I'm going to have each side be like e to the ln of x, e to the 9. So I have e to the ln of x is equal to e to the 9. Well, e to the ln also goes away. Awesome. All right. So e to the ln of x is equal to e to the 9, because that's just x is equal to e to the 9. Go to the next one. All right. We have to get the log by itself. Subtract 7. Both sides. Negative 3 log 10x is equal to 6. Get log by itself. Get log by itself. So divide each side by negative 3. Log 10x is equal to negative 2. All right. So this is supposed to be to the 10 to the x. Okay, this is supposed to be 3 log 10 to the x power, to the x power, to the x power. Okay, so I know secretly this is the common log. So log base 10 of 10 to the x, that's just going to be x equals negative 2. Sorry, that should be x as an exponent. Let's use our properties of logarithms. I know that when I have an exponent in a log, I can bring it to the front. So I have 4 times log base 5 of x is equal to 20. Get log by itself, divide each side by 4. So log base 5 of x is equal to 5. So 5 to the 5th power is equal to x. That's just going to be 3,225. So simplify the log as much as possible before we evaluate it. Oh wait, both of these are the same log base, meaning the inside portion also have to match. Since they both are log base 5 and you know it's equal, I know the left side has to equal the right. So 2x plus x has to equal 20. Okay, move it to left side and move the 20 to left side. So minus 20 equals 0. You can do this, you can factor. So I'm looking for what adds to 1, multiplies to negative 20, be 5 and negative 4. Yeah. Add to 1, multiply negative 20, x minus 4, x plus 5 equals 0. So x is going to equal 4 and negative 5. Alright, okay. Before I can equate the left and right side, I have to actually make it so I have 1 log on each side. Part D, I had 1 log on both sides. That way I could equate the inside portion. So I need to only have one log on the right side. Since this is a minus, this is going to be the same thing as log base 2 of 10 divided by x minus 4. Now that I have the same thing on both sides, I'm going to equate the inside. So 5 is going to equal to 10 over x minus 4. Multiply each side by x minus 4. 5 times x minus 4 is equal to 10. Divide each side by 5. I have x minus 4 is equal to 2. Add 4 on both sides, x is equal to 6. Cool. We could always go in, double check that this is correct. And now comes the fun part. Solve the following equations. Okay. So I see that 3 and 2 are both prime. They cannot be written in terms of each other. I can't write 3 as 2 to some power because I don't want decimals. That's not fun. So I can use a log function, ln, to simplify both sides because I'm wanting to solve for x and x is in my exponents. Okay. This is not going to be great fun, but we'll get past it. ln of 3, 6x minus 3 is equal to ln of 2, 4 minus 4x. Bring the exponents to the front, so I have 6x minus 3. Let's see. 3 ln of 3 is equal to 4 minus 4x times ln of 2. Go ahead and I'll distribute the ln of 3 to each one of these. 6x ln 3 minus 3 ln 3. I'll distribute the ln of 2 to both of these terms. 4 ln 2 minus 4x ln 2. And I'm going to move the terms with the x to the left side and the terms without x's, which are constants, to the right side. So I'll add the 4x ln 2. So 6x ln 3 plus 4x ln 2 is equal 4 ln 2 plus 3 ln 3. Alright, so we're getting close. If I need to get x by itself, the whole issue is like I'm trying to solve what x is equal to. Get x by itself. So is there a common factor? Yes, I can just pull out the x out front. So I have 6 ln 3 plus 4 ln 2. The right side's the same. 4 ln 2 plus 3 ln 3. And I'm just going to divide the whole, like both sides. I'm just going to divide both sides by 6 ln 3 plus 4 ln 2. Notice that the 4 ln 2 does not cancel out because these are binomials. Means they're adding together. So I can't just go and cross those out. That's a no-no. Alright, you can't just cross these out. That's not, you can't do that. But this stuff, this whole thing, like this is the same binomial. So x, just to reiterate, is 4 ln 2 plus 3 ln 3 all over 6 ln 3 plus 4 ln 2. That's it. You could plug this into your calculator, find a number, but it's fine. Alright, let's do C. C is e to the 2x minus x minus 2 equals 0. If I wrote this as x squared minus x minus 2, you could totally factor it. You could factor this into x minus 2 and x plus 1. Well, guess what? Think about it. What is e to the x times e to the x? So normally if I would have x times x, that's x squared. Alright, so I just add the exponents together. 1 plus 1 is 2. E to the x times e to the x is just going to be e to the x plus x, which is e to the 2x. So secretly this is like x squared. Alright, so this is going to be e to the x minus 2 times e to the x plus 1 equals 0. Set each one of these terms equal to 0, so e to the x minus 2 equals 0. So e to the x equals 2. I need to solve for x. Oh my gosh. Take ln of both sides. Ln of e goes away, so x equals ln 2. I can do this one. Alright, so e to the x plus 1 equals 0. e to the x equals -1. I could try that same trick where I take ln of both sides, right? X equals ln of -1. What? That's not possible because logs cannot, we can't do log of a negative number. So, can't log a negative number. Okay, let's do D. This is very similar. Super similar. I have 4e to the 4x plus 8e to the 2x minus 5 equals 0. So if I would have you solve, let's see, I could have 2e to the 2x times 2e to the 2x. Let's see if this works. 2 times 2 is 4, so that would go to 4e to the, well, 2x, e to the 2x times e to the 2x is 2x plus 2x, so that's 4x. Okay, that works. What multiplies, let's see, multiplies a -20, adds to 8, because remember this is a times c, adds to 8, let's see, 10, and -2, so if I divide each of these by 2, I have 5 and -1. Equals 0, so I set each one of these equal to 0. 2 to the 2 times e to the 2x plus 5 equals 0. So 2 to the 2e to the 2x equals -5. E to the 2x equals -5 over 2. That's not possible. My exponential function will never have a negative y value. You think about what does the graph of an exponential look like? It's like this. We don't have any values that are negative there below. Okay, let's take the next one. So 2e to the 2x is equal to 1, because if I add 1 on both sides, right, set equal to 0, add 1 on both sides. Okay, so divide by 2, e to the 2x is equal to 1/2. Take ln of both sides, ln. So 2x is equal to ln of 1/2. Divide by 2 on both sides. X is equal to ln of 1/2. Divide by 2, and that's roughly going to be 0.35. Or wait, is that 35? Something like that. Sometimes I can't read my own handwriting. Okay, so we only did examples, well, A, B, and D in class. We could do example E and F, but that's a little more difficult. I don't want to discourage you guys. You can do A, C, D. B is super similar to A, right? Just like D was similar to C. This one, we just need to, I can start out for you. I can rewrite this left side as ln of 7x plus 3 over x plus 1, and that's going to equal ln of 2x. All right, raise each side to the e, so that goes away. So I have 7x plus 3 over x plus 1 is going to equal 2x. Multiply by x plus 1 on both sides, so 7x plus 3 is equal to, let's see, I'm going to multiply by x plus 1 on both sides. So it goes away. 2x squared plus 2x. Move everything over. 0 equals 2x squared minus 5x minus 3. Alright, so I need to factor this, so this isn't nearly as bad as what I thought. But we will have to check for extraneous solutions. Okay, so what multiplies to, let's see, a times c, so -6 they multiply, and adds to -5. Let's see, what about -6 and 1? -6 and 1, yeah. Okay, if I want to, let's see, there's really only one I could, yeah, so this will go to 2x plus 1 times 2x minus 6, divide each of these by 2. I see my factors are 2x plus 1 times x minus 3. If I FOIL this out, that's 2x squared. This goes to negative 6x. This goes to plus 1x, yeah. And this is negative 3. Okay, so that works. So I see that my solutions are x equals negative 1/2 and x equals 3. So then it's just a matter of plugging in. So if I plug in, if I plug in 3, let's check, pick a different color. Let's check x equals 3. So this would be ln of 3 times 7 is 21 plus 3 is 24 over 4. That's ln of 6. Alright, so that's 6. Should equal ln of 2 times 3, which is ln of 6. Okay, so that checks out. That's fine. Let's check x equals negative 1/2. Yeah, negative 1/2. Alright. I get negative 1/2. Let's see. So ln of, because I'm using this right here, using this line. Alright, so negative 1/2. 1/2 of 7 is going to be negative 3.5 plus 3, so that's negative 1/2 over 1/2. So that's ln of negative 1. Oh my god. Okay, and then equals, what is 1/2 of 2, negative 1/2. Okay, so that's ln of negative 1. This is ln of 2 times negative 1/2 times negative 1/2. So it's ln of negative 1, but the issue is we can't have negatives in my ln, so that's no bueno. Literally my only solution is x equals 3. And then f is similar to that. Okay, cool, so I end up doing E, otherwise that's it. Let me know if you have questions.